All right, so let's do this. We've talked about right triangles. What was the big thing? Was it 7-3 or 7-2? What did we talk about? What was the big topic? Pythagorean theorem. Exactly right. Okay, you remember Pythagorean theorem? Yes?
Yes.
What was Pythagorean theorem? Yep. All right, so now that is a special kind of triangle, but it is a right triangle. So you can use Pythagorean theorem on any right triangle. It doesn't matter, okay? It doesn't have to be any kind of a special triangle. But today we're going to talk about two special right triangles, all right? I mentioned it to you earlier before we started recording. Do you remember what I said? What did I call it? 45, 45, 90, exactly. So I'm going to make this perfect. I'm going to go copy, paste, and then I'm going to, oh, why does it say 270 right there? Well, maybe I won't. Let me see. What if I made this 90? Let's see. Nope, that's not what I wanted. Anyway, I'm not going to try to make it perfect. Why are you flashing? Why'd you have the flash on? All right, I'm trying to make both of these sides equal to each other. So if I make both of these sides equal to each other, you do know the name of that kind of a triangle. What if two sides of a triangle are equal? It's isosceles, right? But this is also, it's isosceles, but it's also what? A right triangle. So it's actually an isosceles right triangle, which means without me giving you any numbers whatsoever, you should be able to tell me what that angle is and what that angle is. It's 45 degrees, right? Because these two angles have to add up to 90. Agreed? If these two sides are equal to each other, we had a theorem ways back that said the opposite angles should equal each other, right? If this is equal to this, then this angle and this angle will equal. If they're both the same and they both add up to 90, what do they have to be? They have to be 45, what? 45 and what? 90. And that's our first special triangle. It's 45, 45, 90. That's the way we refer to it. Okay? And we don't have to say 45, 45, 90 right triangle. We just say 45, 45 what? 90 because the right, there you go. All right, let's do this. When do we get out of here? We're 10 of, right? 50? Okay, so let's, we're only going to do one of these today. There are two of them, but we're just going to do this one today. Okay, we'll do the second one tomorrow. All right, let's see. What do I want to do with this? Let's do this. Let's make this side equal to 1. And let's make, so if both of these sides are equal to each other, what's this side going to be? It's going to be 1 as well. Agreed? Okay. Now, what we're going to do, let's call this C. And let's find out what C is actually equal to. How could we do that? How could I find the length of side C? If I know that's 1 and I know that's 1. Like 1 inch, 1 foot, whatever. Say it. Yeah, do Pythagorean theorem. Exactly right. So it's right here. So what am I going to put in? I'm going to go what? 1 squared plus 1 squared equals what? C squared. All right, let's do the math. What's 1 squared? 1 plus 1 equals C squared. What's 1 plus 1? 2 equals C squared. But I got to get C by itself. Okay, that's not what C is. C's not 2, is it? No. How do I get C by itself? That's it, square root. So what is C equal to? The square root of 2. That is not the same as 2. I got to say this all the time because some people just mix this up. It's not a 2. It's the square root of 2. I think we talked about this number before. Does anybody know off the top of their head what the square root of 2 is equal to? I got a calculator here. You won't be able to see this on the YouTube if you're watching it on YouTube because I'd have to go through, click a couple other buttons, and I'm not going to do that. All right, so watch. Square root, have I shown this calculator before? Okay, so the square root of what? 2 equals, what do you think? Of like a 5 point? 0.5? What does it mean to be the square root of 2? What number times what? Itself is equal to 2. So it's going to be 1 point something. Exactly right. I think it's 1.414. Let's see what it is. Oh, there it is. Look at that. 1.414, blah, blah, blah. And it keeps going. It never stops. It doesn't stop at this 2 here on the end, okay? It just keeps on going. They call it an irrational number. Let's write that down. Irrational. Oops, I got to get rid of this. Everybody saw that already, right? So let me get rid of... If you're watching this on YouTube, I have a calculator, a graphing calculator up on the screen, but I got to push some buttons for you to see it on YouTube, and I just didn't want to do that. So the square root of 2 is approximately 1.414, right? Or 1.4, let's say. But I'm not going to use the 1.4. Let's keep it the square root of 2, but I'll take this time to say this word, irrational. It's called an irrational number. Rational means you could write it as a fraction. Like 1/3. What is 1/3 as a decimal? 0.3, and it keeps going, doesn't it? It keeps repeating. A lot of times you put a little bar over top of it, right? Or you could do what? Put a little ... You with me on that? But it repeats. It repeats the same pattern. Agreed? What if you had a fraction like 1/2? Just make this super easy. What's that? That's 0.5. And it doesn't keep going, and it doesn't repeat, but it does stop. Everybody got it? But what about the square root of 2? It's 1.414. I forget what the rest of the numbers were. I don't think it had a 0 in there. Yeah, whatever it is, okay? But it doesn't repeat the pattern. Does it keep going 4141414? No, it didn't, okay? It doesn't repeat a pattern. So when you have a situation like that, they call it an irrational number. You cannot make a fraction out of it, except for saying maybe like the square root of 2 over 1, but you can make anything over 1, agreed? So anything that you can make a fraction out of, that's called a what? Rational number, ratio, right? The word ratio is in there. Ratio means you're comparing one thing to another. A fraction, agreed? Irrational, what do you think that IR in front of it means? It means it's not a rational number, okay? It means it's not a rational number. All right, enough of that. I didn't mean to go off on that. What I really want to do is look at that square root of 2. Let's get rid of all that mess. Okay? What I really want to do is look at that square root of 2, and we're going to do one more thing. Well, I'm going to do maybe a couple times. Watch. I got some time, so let's do this. Let's pick another number, a relatively easy number. Give me a smaller number. What do you think? 2? All right. Let's call that 2. Let's call that 2, and let's solve for C. All right? What I'm trying to do is establish a little pattern here, all right, so that you can see what's going to happen. All right? So let's solve for C if both those sides are 2. Let's see it. It's 2 what? Squared plus 2 squared equals C squared. 2 squared is 4 plus 4 is C squared. 8 equals C squared. What's C equal to? The square root of 8. Okay? Let's simplify this, okay? This is something we've just touched on very briefly. Remember, I keep saying, well, this is something you probably should have learned in Algebra 1, but I'm going to do it again. So what is equal to 8? What times what is equal to 8? Well, 4 times 2 is 8, correct? I put that under a square root. You remember this rule, don't you? If I have things multiplied together under a square root, what can I do? I can put them both individually under their own square root. There's a rule in algebra that says I can do this. Algebra. Okay? You should have learned it. Apparently you didn't. It's not your fault, but that's where it is. Now you've learned it, okay? So you can't say that you didn't learn it. Now, what is the square root of 4? It's 2. All right, I'm going to put C equal. I'm just taking this and putting it over here. So the square root of 4 is a 2, isn't it? And then how do I write that? It's 2 what? Times the square root of 2. Okay? I'm writing that for a specific reason. I'm going to get rid of all of this just to give myself some room. Okay? So look at what C is now. C now is 2 times the square root of 2. What was it when the sides were 1? It was 1 times the square root of 2. When the sides are 2, what's the hypotenuse going to be? 2 times the square root of 2. Take a wild guess. What if the sides were 3? You got it. If that's 3 and that's 3, what do you think C is going to be? It's going to be 3 times the square root of 2. Let's just do it one more time just to prove to you that it's true. Okay? Is that all right? So what if, and that's why I want to pick little small numbers to make this easy for us. You can, but the math on the Pythagorean theorem just gets a little complicated. You can always use a calculator. It's not that big of a deal. But to simplify the square root sometimes is a pain. So that's why we're just using little numbers. So 3 squared plus 3 squared equals what? C squared. So that's what? 9 plus 9, yes, equals C squared. That's 18 is C squared. So what's C? Square root of 18. Let's break down the square root of 18. Now, there's a couple things that multiply to become 18, right? There's 2 times 9. There's 6 times 3. But there's something else. What is that? 9 times 2. I want to use 9 times 2. Why? That's right, because I can take the square root of 9. Okay? Everybody see that? You could do it the other ways. I'm not here to teach you this stuff really today, but this is the best way to do it. So what's the algebra thing say I can do? I can put them both under a square root. What's the square root of 9? 3. And that's 3 times what? The square root of 2. It's just like we thought it would be. Agreed? All right, so when we did the 1s, that kind of made sense, didn't it? All right, then we did the 2s, we did the 3s. What if, we're not going to do the math, what if that side was, I don't know, something weird, 17, and that was 17? What's the hypotenuse going to be? You got it. Now you're getting somewhere, okay? This is a special triangle. When you have a 45, 45, 90 triangle, you know the 2 legs are going to be exactly the same, right? That's the only way that you're going to have both of these 45, right? We talked about that at the beginning. So if both of these are the same, how do you find the square root, or how do you find the hypotenuse? It's always the leg times the square root of 2, okay? Or the square root of 2 times the leg. So let's write that down. Let's write it down the last way I said it. So on a 45, I'll write it all together so it's nice and compact. On a 45, 45, 90 triangle, the hypotenuse is equal to how much times the leg? The square root of 2 times the leg. You got it. The square root of 2. I'll put a little x for multiply. We don't normally do that, but we're going to do it this time, okay? So this is what's important to remember. This is super important. Now, on a 45, 45, there's only really one thing to remember, and that's it. That's it right there, okay? We're going to do another one tomorrow, and it's called a 30, 60, 90 triangle, all right? But we're not going to do that right now. We'll do that tomorrow. But this is the square root of 2 times one of the legs. Everybody got it? So I could give you, let's do a couple more that are, I'll just keep that right there just so you remember it. So make sure you write that down, put it in a box, okay? Little stars next to it, put little bells and whistles, color it nice and pink or something where it pops out at you, all right? This is something you have to know, all right? So let's do another one. I'm just going to redraw a 45. 45 again. Now remember, if it's 45, 45, the 2 legs are always what? The same. Okay? What if I didn't give you a nice whole number? What if I said that this was the square root of 3 and I asked you to find the other 2 sides? Well, one side's super easy. You don't have to do any math at all. What's the other side? What's this side? It's not 3, it's what? It's the square root of 3 because these 2 sides are the same, right? If this is 45 and this is 45 degrees, I should put. If they're 45 degrees, that means this leg and this leg have to be exactly the same, all right? You don't take half of it. It's nothing like that. They're just the same. Everybody with me? What if I ask for the hypotenuse? You got it. It's the square root of 2 times the square root of 3. It's always the square root of 2 times whatever your leg is, all right? Now, it's weird that they're square roots, but we can do, well, you guys can do very, very little with square roots at this point, but hopefully we'll learn some more. By the time you get to Algebra 2, you're going to learn a ton of stuff, okay, with the square roots. But at least I gave you a little head start in here. What's the square root of 2 times the square root of 3? That's it. This is the square root of 6. All right? There's nothing else you can do with that. So what is the hypotenuse? It's the square root of 6. And we just keep it like that. If you put it into a calculator, you would get an approximation. All right? This right here is an exact answer. Okay? That's exact. When you put it into a calculator, that decimal will keep on going forever and ever. Agreed? Because it's an irrational number. All right? So that's not exact. That's an approximation. If you want an exact answer, you just keep it the square root of 6. Now, what if you were like, I mean, it's weird that you would have a square root of 3 right here, but what if you were doing like real work, like you were doing carpentry work, and you had to cut the length of to make this the hypotenuse. You knew what this length was, and you knew what this length was. You needed to figure out how long does the hypotenuse have to be, right? Then what do? You just take whatever the leg is, you measure it, multiply by square root of 2, and you cut this, right? Now, do you have something on your ruler that says the square root of 6? No, of course not. So what would you do? You would put it into a calculator and get an approximation. You with me on that? All right. So approximations are good. We use them all the time. But in a math class, we're going to keep things exact. All right. Everybody with me on that? So that's the way I would want your answer, just like that. All right. Let's do another one. It's a little bit different. I'll tell you what, let's use the same triangle so I don't have to redraw the triangle. Let's get rid of all this mess. Okay. And what if I do this? I'm really going to turn the tables on you a little bit. Okay. What if let's see, did I do that in here? Yeah, I'll just use the example they give in the book, okay? I was just going to make one up, but let's say they tell you that that's 12. And you have to find this leg and this leg. Well, once you find one leg, the other one's easy, right? Why? Because they're the same, right? What if they give you the hypotenuse, though? What do you think you're going to do? Are you going to go 12 times the square root of 2? No. You would divide it by the square root of 2. Let's show you why. All right, what was our little formula? I'm just going to rewrite it. Hypotenuse is what? Square root of 2 times the leg. Okay, we'll call the leg x. Okay, so if that's x, what's this have to be? That also has to be x. Don't call it y because they're the same exact thing. Okay, so let's plug the numbers in. What do we know? Do we know the hypotenuse? Yeah, it's 12 equals what? Square root of 2 times what? The leg, which I don't know. I called it x. Okay, look at the math now. How do I get x by itself? Divided by the square root of 2. So divide this by what? The square root of 2. Does that make sense on why you divide it by the square root of 2? I mean, you guys intuitively, right, with your intuition, you said, oh, if I know this leg, I multiply it to get the hypotenuse. But what if I know the hypotenuse? How do you get to the leg? You just do the opposite, right? You divide. So it does make sense that you divide by the square root of 2. Agreed? Yeah, and there it is right there, right in front of you. Let me show you. I got some time. I'm going to show you. You could stick it into a calculator. I almost hate to say this, but in a geometry class, in this geometry class, I'm almost okay with you keeping it like that. I almost hate circling that because math teachers don't want you to divide by the square root of 2, right? I looked it up sometime, and you can ask Mr. Rao. He kind of explained it to me because I even asked him. I was like, who said we can't divide by the square root of a number? And he gave me an explanation for it, and I tell you the truth, that was like 2 or 3 years ago, and I forget what the explanation is. But you can look it up, Google it, see why can't you divide by a square root? But mathematicians don't like it, okay? They do not like a square root in the denominator. Why? I don't know. They just don't. And every teacher, every single teacher you're ever going to go to is going to make you simplify this, okay? And we simplify it by a method called rationalizing the denominator, okay? Rationalizing the denominator. I'm not even going to write that down. That's definitely a later Algebra 1 topic, definitely an Algebra 2 topic for sure, okay? You're going to be doing this a lot. So let's take it. So we've done the geometry. This is 12 divided by the square root of 2, whatever that comes out to. And if I put a approximate, it comes out to about 8.5, okay? in a calculator. So that's 8.5, that's 8.5 approximately. But we got 5 minutes, so let me show you some algebra. You okay with that? Because you're going to have to do this next year, so you might as well. So when you get to Algebra 2 next year and they do this stuff, you're like, oh yeah, that's that stuff Mr. Hamrick was telling us about, okay? So hopefully you remember. So watch. Here's what you're going to do. You don't want a square root in the denominator. Math teachers don't like it. You don't like, not just teachers, but mathematicians don't like square roots in the bottom. Got it? So that's not simplified. People consider that not simplified. So what we're going to do is we're going to get rid of it from the bottom and we're going to put it on the top. Now I can't just take this and then chuck it to the top. I can't do that. All right? There's no rule that says I can do it. But let me do a little bit of prep work for you first. Okay? What if I said, what's the square root of 3 times the square root of 3? Square root of 9, good. Which equals what? 3, good. All right, let's just do 2. I was going to save it for down here, but let's just do it now. What's the square root of 2 times square root of 2? Square root of what? 4. What's the square root of 4? It's 2. Let's pick someone, not a big crazy number, not like 10,000 or anything. Pick a relatively small number, but a little bit bigger than what we have here.
No, let me pick. Come on, 50.
6. I like 6. Okay, square root of 6 times square root of 6. What's that? Square root of 36. What's the square root of 36? It's 6, isn't it? Okay. What are we really doing to these two? We're multiplying it by itself. Multiplying that by itself, multiplying that by itself. What are we really doing when we multiply something by itself? We are 2 times 2, 3 times 3, 4 times 4, 5 times 5. What are we doing? We are squaring it. That's right. So basically, when I multiply a square root, I'll say x, by itself, what are we doing to it? We're squaring it, which basically does what? Cancels each other out, and I'm just left with whatever the number is. Okay? You with me on that? So, here's what we're going to do. With that said, and look, every time I did that, what did it do? It got rid of the square root, didn't it? See, I'm left with a whole number every single time. What if I had some I will do some crazy number now. What if I had 723 times the square root of 723? Do I have to know what 723 times 723 is and then take the square root of that? No. What's going to happen? It's just what? 723. You get it? All right. So, what's the square root of 2 times the square root of 2? That'll get rid of the square root, won't it? Because what's the bottom now going to become? It's going to be a 2. But I can't just do that to the bottom. What else am I going to have to do? I'm going to do it to the top. Why? Is it because whatever I do to the bottom, I do to the top? That's not the reason. It's not whatever you do to the left side, you do to the right side. Okay, this is a what? What's anything divided by itself? It's 3 divided by 3. What's 7 divided by 7? What's 1,000 divided by 1,000? What's the square root of 2 divided by the square root of 2? It's 1. Okay? Everybody got that? So I'm allowed to multiply anything by a 1. And it doesn't change the value of it. Would you agree? What's 7 times 1? 7. Same thing that we started with. What's 248 times 1? 248. Got it? So what is this times 1? Well, it still equals what we started with. Yes? All right. I'm getting there. So what do we have now? What's the square root of 2 times square root of 2? It's 2. What do I do up here? I just write 12, what? Times the square root of 2. Let's get rid of this mess. We're almost done. Now, we got rid of the square root in the bottom, didn't we? We just multiplied it by itself. That's how you get rid of it. It's how you get rid of a square root. You multiply it by itself. And then we have to multiply the top by the same thing. But we're almost done. We're almost done simplifying. What can we do now? This 2 and this 12. It goes 6 times. That's right. It goes 6 times. So, what is the simplified answer of 12 divided by the square root of 2? It's nope, it's not divided by anything now because that 2 canceled out, right? It's just 6 times the square root of 2. You're like, there's no way. There's no way that that equals that. Well, how could you figure out if they really do equal each other? Yeah, let's try a calculator, all right? Now, again, on YouTube, I'm bringing out the calculator. And we're putting it in here. Let's do it real quick. Watch. 6 square root of 2. And that's equal to that number right there. Everybody got it? Watch this. This is 12 divided by the square root of 2. Look at that. Same exact number. Everybody see that? 8.48 whatever. Okay, remember I said it was 8.5? Yeah, that's where I got the 8.5. But 6 times the square root of 2 is the simplified version of 12 divided by the square root of 2. Okay? So, that is...
Isaiah Boyer to the office, please. Isaiah Boyer to the office.
Yep.
Thank you.
That's all I have for today. Tomorrow, we're going to do another... Did I tell you what the other triangle was?
No.
30, 60, 90. That's right. So tomorrow, we're going to do 30, 60, 90. Did I give you any homework?
1 through 16, right?
1 to 16. You may not... Now, do this. Everybody listening? People are walking out on me. Not listening. Actually, I'm not going to put a box around that. So, would I say 1 to 16?
Yeah, 1 to 16.
Okay, now, listen. If there are triangles on there that are 30, 60, 90, don't do them. Only do the ones that are what? 45, 45, 90.
I did
Okay.
because I taught myself to turn it in.
Tomorrow.
And
Yeah.
I have one from Thursday because I wasn't here.
All right. If you have that, I'll take that one. All right, everybody good? So just do the ones that cover the 45, 45, 90 one.